Solving cubic equations. You can generalize the rule for the roots of quadratic equations to any polynomial with real coefficients. In the previous section, we studied the property of the roots of quadratic equations when they are given as complex numbers. We said that they occur as a conjugate pair. This rule can be generalized to any polynomial with higher degree than 2, maybe of degree 3, to be a cubic equation, or degree 4 to be a quartic equation. If f of z is a polynomial with real coefficients and z1 is a root of f of z equals to 0, then the conjugate of z1 is also a root of f of z equals to 0. So if given a polynomial with real coefficients where we have to solve this polynomial equals to 0, if one of the roots is a complex number, then the other root of this equation will be the conjugate of this complex number. Note that if z1 is real, then the conjugate of z1 will be the same as this number. You can use this property to find roots of cubic and quartic equations with real coefficients, where an equation of the form az cubed plus bz squared plus cz plus d equals to 0 is called a cubic equation and has 3 roots. So we have a polynomial of third degree equals to 0, so we have a cubic equation. Whenever we have a degree of 3, then this equation is said to be cubic. For a cubic equation with real coefficients, either all 3 roots are real, as we said we have 3 roots, we may have all these roots are real, where a real valued cubic equation might have 2 or 3 repeated real roots. So among these 3 roots, we may have 2 repeated roots, or the 3 roots are repeated. Another case for the roots is that we may obtain one root is real and the other 2 roots form a complex conjugate pair. Among these 3 roots, we have one real root and the other roots are complex conjugate pair. So that is the introduction to the solution of cubic equations. Remember that we have 3 roots. We may have these 2 cases. Either the roots are all real or we have one real and 2 complex conjugate roots.